Okay, so for the analysis, it's really straightforward, but you gotta follow the instructions to the letter or you lose big marks. Okay, so in question number 1, it wants you to write the chemical reactions, 1, 2, 3, and 6 and 7. Okay, you don't have to do 4 and 5 because they're already done anyway. Okay, so what you need to do is write out the reactions as they happened. Now we're going to talk a little bit about some of those and you'll get a big juicy hint for 1 and 2. Okay, the rest of them, they probably went exactly the way you predicted, and all you have to do is write out the reaction in formula form and in words for each of the reactions. Okay, everybody follow me there? That's question number 1. Write out the reaction in formula form and words. Make sure it's balanced. That's question number 1. Now, your help for question number 1 is with reactions 1 and 2, or A and B, okay, or pair 1 and pair 2. So in pair 1 yesterday, we predicted this as a double replacement reaction and we just swapped the metals. But what did you observe in that reaction? Oh, something definitely happened. Yeah. What did it smell like? Window cleaner, smelling salts. I've had some people say cat pee. Okay? All of those are true because all of those things contain this gas. Ammonia. Okay? That is one of the products of that reaction. Okay? Ammonia is produced as a gas in that reaction. It doesn't look like anything happens. Okay? It doesn't even bubble and fizz, but you can detect that being released from the reaction. Okay? Now, where does that nitrogen and 3 hydrogens come from? They come from right here. Okay? So, if I take that nitrogen and 3 hydrogens out, I'm left with a chemical reaction between sodium hydroxide and hydrogen chloride, a double replacement reaction. So if you now, from here, use that as the rest of the reaction, you'll get the other 2 products. Okay, this reaction actually has 3 products. Okay, nitrogen trihydride and the 2 products of this remaining reaction. Okay? A similar thing happened in reaction number 2. Okay? When you mix vinegar and baking soda, what does it do? Bubbles and fizzes, right? When it bubbles and fizzes, what is getting released? A gas. Okay? The gas in particular in this reaction is carbon dioxide. Okay? So that's one of the products of that reaction. There are 2 others. And very similar to pair number 1, okay? When that gas is produced, that is going to take care of this here, and it's going to leave 1 oxygen behind. So now you have a double replacement reaction between these 2 things. That's what's left. Once that is produced, the rest of the reaction is acetic acid reacting with sodium hydroxide. Okay, so you're still going to write out these reactants. These were the reactants, but this double replacement reaction will help you to predict the other 2 products in that reaction. So pair 1 and pair 2 are a little odd, okay, but we can still predict what the products were now that we know what the gases were and where they came from. Okay? For the rest of the pairs, except 4 and 5, okay, you predicted them yesterday, they went just as they should have. All right, so all you have to do for each one of these, okay, is write out the reaction in formula form and in word form. So products. So you've got a formula reaction and a word reaction and the formula reaction is balanced. Okay, that's question number 1. Question number 2 wants you to tell me what the precipitates were. Okay, you had 2 reactions that produced precipitates. Okay, pair 3 produced a precipitate, okay, a white one, and no, yeah, it was pair 3. Hang on, I gotta double check that. Pretty sure it was pair 3. Pair 3 was, yes, A and E. Yeah, pair 3 and pair 6. Okay, both produced precipitates. One was white, the other was yellow. Right? So what question number 2 in the analysis is asking is, when you write out the reaction, okay, so if your reaction goes like this, A plus B, or AB plus CD, okay, gives AD plus BC, it's asking which of these 2 products was the precipitate. How do you figure that out? Do you have a chart somewhere that helps you to figure out what things are soluble and what things are not? Okay, so what you've got to do is look at your products for pair 3 and for pair 6 and figure out which of the products of those reactions are not soluble. Those would be your precipitates. And all you have to do is write down, in pair 3, the precipitate was this compound. In pair 6, the precipitate was this compound. Okay, everybody follow me there? Okay, so for the analysis, question 1, reactions written out in word and formula form balanced. For question number 2, what are the 2 precipitates? Okay, questions on the analysis. Then for your conclusion, same as before, copy and paste your hypothesis, and then give me an explanation as to why what happened in the lab supports it or rejects it. Okay, so if you said in your hypothesis, the signs of a chemical reaction are A, B, C, and D, okay, and you saw all of those, then in your conclusion you say, well, the hypothesis can be accepted because in our observations, A, B, C, and D were observed. Okay? These indicate that something occurred, and you tell me what it is. All right? Everybody follow there? And then, sources of error. 2 of them. Okay? 2 sources of error. Guys, after marking your labs yesterday, which we're not going to get a chance to go over today, okay? But after marking your labs yesterday, we need to clarify what counts as error. You screwing up is not an experimental error. It's a human error, and it's correctable. Okay? I don't know how many times I read in there, yeah, we messed this thing up, so our results probably aren't very good. Ooh, don't say that. Okay? That is not what you want me to see. Okay? If you mess something up, you do it again. And you never tell me. Okay? That's how science works. If you mess it up, you do it again. You fix it, and you do it right. Okay? Your sources of error need to be things that were part of the experiment. So in that first lab, sources of error could have been things like the amounts of the substances were not accurately measured. Therefore, that could give an unfair advantage in a solubility test or in a conductivity test because nothing was measured exactly. Okay? Or you could have said that maybe the temperature in the room went up a little bit during the lab, and that could have affected the solubility of things. That's not something you had any control over. You followed the instructions, and these things happened. Those are experimental errors. They were things you could do nothing about in the lab. Okay, does that sort of make sense, what I'm looking for instead? Okay, but you don't want to say, yeah, I messed up. Okay, if you say, yeah, I messed up, you messed up big. Okay, bigger than you think. Okay. All right, so this isn't due until next week. I think I made it due Thursday. But a couple of other things you want to be aware of. Your unit exam date has been set. It's March 14th. That's 2 weeks from today. Okay, so make sure you're ready for, we only have the rest of prediction and the mole equation left to do. Right, so we've got lots of time. I will put a review package on Google Classroom next week sometime, so you can start looking over that. It's actually like a package of things to do, and then there's a practice test for you to take. It's a really good idea for you to do after you've studied. Right, so that's the kind of stuff that is coming up here. Okay, tomorrow at the start of class, we're going to go over your lab reports. We didn't get a chance to do that today. They were returned to you yesterday. Okay, you can check your mark. But we're going to go over them. So if you have questions, you're not sure maybe where you lost your marks, we are going to go over that today, okay, or tomorrow, sorry, first thing, so that you get an idea. Okay, questions from you guys? Okay, you still got like 7 minutes or so, or 6 minutes or so. I would say good time to work on the lab report. Yeah, talk to your partners or whatever and see if there's anything. Okay, maybe you can work on reactions, getting the reactions written out correctly. Not a bad plan.